Hey guys, our last section of the class. Still on probability. Anyways, here we go. The last lesson to teach. Usually this isn't how I picture my last lesson of the year, but what a semester it's been, right guys? Alright, so compound events is what today's lesson is about, and compound events is the probability of two or more events happening at the same time. There are two types of compound events. The first one is called an independent event. The second one's called dependent. We'll talk about that in a second. So independent events are events that do not influence one another. Think about independence, when countries gain independence from another country, or how you want to be independent from your parents and do things on your own, things like that. If you have two events and we ask for the probability of A and B, and they're independent, meaning that they don't influence each other, you take the probability of A times the probability of B. Seems easy enough, right? So let's look at a problem. Number one, you roll a red die and a blue die, just two different colors to keep it straight which one we're asking about what. What is the probability you roll a 3 on the red and an even number on the blue? Okay, so these two events, rolling the red die and rolling the blue die, these are independent events because they don't influence each other. Oh, I wish my son left another dice up here. But he didn't. I'm trying to see if I see one. But anyways, when you roll two dice, right, if I had two in my hand, I just roll them and I let them go, they're not going to affect each other. Pretend there was another one there. That's why they're independent. They are events that do not influence one another. So we want to know what's the probability. We have a 3 on the red and an even on the blue. So that means, following my formula, I take what's the probability I get a 3 on the red, and I multiply by the probability of an even number on the blue. Alright, so let's just think about a die for a second. We want to get a number 3. Well, on the die, we talked about this last lesson, there's 6 sides, 1 through 6, and how many have the number 3 on it? Just 1. So it's 1 out of 6, because there are 6 sides on the die. Now, thinking about the other die, the blue one, there are still 6 sides. How many of those are even numbers? 2, 4, and 6, which is 3 out of the 6. I'm going to simplify that to make my life easier as 1/2. Multiply across, because that's how you multiply fractions. 1 times 1 is 1. 6 times 2 is 12. My answer is 1/12. It is as easy as that. Let's look at number 2. You have every letter of the alphabet on a piece of paper, and for those of us who may forget, there are 26 letters in the alphabet. Sometimes I am asked that every year when we do this problem. You choose a paper at random. Again, we are assuming that all the papers are the same size, they're all folded the same way, and they all have an equally likely chance of being chosen. So you choose a paper at random and then replace, that means put back that paper. You choose again. So you have papers in a bowl, you pick a paper, look at it, put it back, and then you choose again. So you're doing 2 picks from the bowl. So 3 different questions. What's the probability you get an A on the first pick and an E on your second pick? Okay, so out of those 26, or let me rewrite it. Some people might like the equation, sorry. So because these are independent events, let me back up. Because when you go and you want to get an A, you picked that paper from the bowl, you looked at it, and then you put it back. So when you go to choose the E, the playing field is the same. There's still 26 pieces of paper in the bowl. Nothing has changed. They haven't influenced each other. You're going to see in a second how they can influence each other. Okay? So, really you're asking, what's the probability of A times the probability of getting an E? Okay? So getting an A, there's only one A out of the 26 letters in the alphabet. And there's only one E out of the 26 letters in the alphabet. So I multiply across. 1 times 1 is 1. And 26 squared, or 26 times 26, is 676. That's your answer. Part B, you get an A and an A. Okay, so these are independent still because nothing's changed. I make my first pick, look at it, might be an A, it might not, and I put it back for my second choice to get an A again. So once again, what's the probability of the first one's an A? 1 out of the 26. What's the probability the second one's an A? It's the same thing again. No matter what 2 letters I put here, even if they're the same, for this setup, all of those answers are going to be 1 out of 676. Same thing, a B on the first, a Z on the second pick. What's the probability of getting a B times the probability of getting a Z? Well, 1 out of the 26 are B, 1 out of the 26 are Z. Once again, like we just said, it's the same exact answer. I'm going to show you how this is going to change. So these are all independent events. The second type of compound event, which we just said, remember, are 2 events that happen at the same time, are dependent events. These are events that influence each other, meaning the occurrence of one event affects the probability of the second. So if we ask what's the probability of A and B and they are dependent events, we take the probability of the first and then we multiply the probability of B, the second event, after A has already happened. And that's usually a little confusing until people see an example. So here we go with our example. Now, number 3, this is the same situation as number 2, so we have the 26 letters. But this time, instead of putting that piece of paper back, you're doing it without replacement, which means after you pick that piece of paper on the first try, you're not putting it back into the bowl. Okay, and so these are dependent events. So I have probability of A times the probability of E after A has happened. Okay, so let's look at probability of A. First choice, I go in, I take my piece of paper, only 1 out of the 26 letters has the letter A on it. But now remember, it was without replacement. So after you chose that piece of paper, you're holding on to it or you're putting it to the side. You're not putting it back in the bowl. So usually this is the easiest way for people to see it first. Instead of having 26 pieces of paper in the bowl for your second pick, how many are left? The answer is 25. There's now 25 left in the bowl to choose from, because after that first pick, whatever it was, you took that piece of paper and set it to the side. You didn't put it back in the bowl. Okay? So out of those 25 letters, how many are the letter E? There's still only one E. So I multiply across. 1 times 1 is 1. 25 times 26 is 650. And that's your answer. Okay, you might think all of these are going to be the same, but they will be a little different. So now, these are the same questions, if you notice, I just were doing without replacement. So A and A. So probability of A times probability of A after A. That's confusing.
There it is, right there.
All right, so again, on that first pick, probability of A, it's still 1 out of 26 because there are 26 pieces of paper in the bowl and one of them is the letter A. Now remember, that piece of paper that you chose on your first pick, it's not getting put back into the bowl. So what is your new denominator? It is now 25. Because you had 26, you didn't put a piece of paper back, it's 25. Now though, if you picked an A on the first one, for that second A, how many are left if you want to pick that same one again? Is that possible? There are 0 A's left. Because you picked one on the first, and it's to the side, there are no longer any A's in the bowl. So 0 times anything is 0, meaning this cannot happen. The probability of this event is 0. It will not occur. Cannot happen. And the last one, B and Z. This is like A. So probability of B times probability of Z after B. Okay, so you have 26 letters in the bowl. How many are the letter B? 1. You chose the paper, you put it to the side. How many are left in the bowl? 25. Out of those 25, how many are the letter Z? 1. So this is the same answer as part A, 1 over 650. So again, to recap here, anytime you see with replacement, those are independent events. Anytime you choose something, you choose candy, you choose a thing of soda, and then you put it back, that's independent events. They're not going to affect each other. The denominators are not going to change. Anytime you see without replacement, meaning you're not putting those items back, you ate a piece of candy, you drank the soda, you gave money to a friend, you used your money to pay for something. Those are dependent events, and that's going to change the denominator of the second event by 1.